Hey guys, this is Test 38 Game 1. This is the clown car game. It's an ordering game. We know this because the clowns get out of the car one at a time, so there must be an order in which they get out of the cars. So we've got all these rules here. They're all before and after rules. So for this reason, we want to diagram this game in a loose, open-ended style. So I recommend essentially branching the variables to show their relationships to each other. I've got the variables listed right here, Q, R, S, T, V, W, Y, Z, and so I'll diagram the rules one at a time, linking them together as I go. So the first rule, V is before both Y and Q. I've got V right here. It's before Y and before Q. Next, we've got a rule involving Q as well, so I can link it in. If Q is after Z, then Z must go before Q. Next, T is before V, so I'm going to branch that right away, just that first part. T is before V, but after R, meaning that R is before it. Then we've got S is after V, so I'll link that in as well. And finally, R is before W. So this is every variable linked together into one big web of relationships. We see that R is before T, V, S, Y, and Q. We see that Q is after V, T, and R. But R isn't necessarily first. I mean, although it is before W, T, V, S, Y, Q, Z is not related to R. So for that reason, Z could be first. And we don't know who's last. Any of S, Y, Q, or W could be last. And a variable like Z, for example, could be anywhere from 1 through 7. The only thing Z relates to is Q. So we know that Z cannot be last. Similarly, W is very open-ended. W could be anywhere from 2 through 8. It simply cannot be first. W does not have to go before T, V, S, Y, or Q just because it appears to the left of them. W and Z are the most ambiguous variables of this game. They create the game's ambiguity. If we got rid of them for a moment and said, okay, we're not going to have any W in this game, we're not going to have any Z in this game, it would be much simpler. We would just have R, T, V on 1, 2, and 3 respectively, then have S, Y, Q interchangeable on 4, 5, and 6. It is the introduction of W and of Z that creates all of the game's ambiguity. So we want to think a lot over the course of this game about where W and Z are going, how they are affected by the restrictions placed in the questions throughout the course of the game. Anyway, let's go on to the questions now. So question number 1, typical orientation question. We just want to take one rule at a time and apply that rule to all 5 choices, typically looking for violations. But because we've related the variables so much to each other in our initial setup, we don't even need to do that. We could simply take each choice and run it through our diagram itself because the diagram shows how everything relates. So looking at A has T first, automatically bad because R has to go before it. For that reason, A is gone. Next, Z first, that's okay. Z could be first. Z could be anywhere from 1st through 7th. Z could go in the front and have everybody else after it. So that's okay for now. So let's say if we had Z, R, W, looking fine so far. Then we have Q, T, V. That's backwards. Q needs to go before T and V. I'm sorry, Q needs to go after T and V. We have the ordering T, V, Q that is fixed, although not necessarily immediate. Q has to go after T and V, not before. So for that reason, B is gone. Next, R, W, T, V. Looking good. R, W, T, V is fine so far. Then we have Q, Z. That's bad because we've got to have Z before Q. For that reason, C is gone. Next, D, Z, W, R, T. We've got Z, R, W. W has to go after R, not before it. For that reason, D is gone, leaving E by process of elimination for number 1. I do want to emphasize that if you wanted to take one rule at a time and apply it to all 5 choices looking for violations, as we typically do, that would have been fine as well. You still would have arrived at the correct answer as well for number 1. Next, number 2, general could be true question. Just run through the choices using the main diagram. Could Y be second? No, because Y has to have at least V, T, and R before it. For that reason, A is gone. Could we have R on 3? Well, R doesn't have to be first. It could be second, but the only thing that could ever go before R is Z. So for that reason, R could never be third. The latest R could ever go is second, since Z is the only thing that could go before it. For that reason, B is gone. Next, could we have Q on 4? Well, we've got to have R, T, and V before it. So for that reason, it might appear like Q could be fourth, but we've also got to have Z before it as well. So we've got to have R, T, V, and Z occurring before Q. So for that reason, the earliest Q could ever appear would be 5, having W coming after it. So for that reason, C is impossible as well and can be eliminated. Next, D, could we have S on 5? S is pretty open-ended. I mean, we got to have R, T, and V before it, so S could never be any earlier than 4. But then we could also throw W or Z or Y before it as well, making it 5. So for that reason, D works and is our answer. I will look at E though. V on 6. V's in the middle of a lot of things, but the only things that could go before V would be R, W, T, and Z. Everything else has to come after it. So for that reason, the latest that V could ever appear would be 5, having S, Y, and Q after it on 6, 7, 8. So for that reason, E is gone for number 2, leaving D as our answer. Next, number 3, if we had Z on 7. So they're limiting the scenario further here. If Z was on 7, we'd have to have Q on 8 coming after it, and then everything else would have to come before. So what would this diagram end up looking like? I would recommend, if you like, creating a more specific diagram for this question. You don't have to if you become comfortable enough with these games over time, but for now I'm going to show you. If we had Z on 7 and Q on 8, everything else, R, W, T, V, S, Y would have to come before it. So I'm going to draw what that looks like. If we have Z on 7, we have S and Y coming before it there. Then before those guys, we're going to have V. We're going to have V, and then we're also going to have, of course, T and R. There is still a good amount of ambiguity, though, because W could appear pretty open-ended. W could be as late as immediately before Z, or it could be all the way immediately after R. So W could be anywhere from 2 through 6 and would be our most open-ended variable here. R has to go on 1, and then T, V, S, and Y are going somewhere between 2 and 6, although we don't know precisely where. So putting a Z on 7 forced W to come a bit earlier. So when they ask us what could be true, W is the most ambiguous variable. W could be anywhere from 2 to 6, so of course W could be on 5 as choice C says and is our answer. I will look at the rest though. Could R be on 2? No, R has to be 1, so A is gone. Could T be 4? Well, we could have W before it being on 2 and then have T on 3, or we could have W on 3 putting T on 2, but there's no way that T could ever be 4 in particular, so B is gone. Could we have V on 6? If we put W before V, V could be as late as 4. If we put W after V, V could be as early as 3, but still never on 6, so D is gone. And then E, Y on 8, no, Q's on 8, that's gone, leaving C if you didn't get it before. Next, number 4, if we put T on 4, what must be true? Again, if you want to draw the local diagram, I'm going to draw it for you here. Of course, as time goes on, if you become more comfortable, you can just do it in your head or do it by, making some light pencil markings on the diagram, on the main diagram itself. I'm going to draw it here, though. If T's on 4, V will have to go on 5, no question about it, because Z would have to come earlier. It would have to be one of the first 3 in order to allow T to go as late as 4. So we're going to have, before T, we're going to have W, and then we're also going to have R coming even earlier, given that R is always before W, and then we're going to have Z occurring before T as well somewhere. And then everybody else, S, Y, and Q, will have to come, S, Y, and Q will have to come after it, yeah. And then we have those guys going on 6, 7, and 8. We don't know precisely how they're being laid out, but that's the general idea. So RWZ anywhere from 1 to 3, while keeping with that order. SYQ on 6 to 8. So what must be true? R on 1. R could be on 1, but it could also be on even 2, so A is gone. Could we have Z on 2? Again, not specified. Z could be on 2, on 1, or on 3. It's open-ended. W on 3. Again, W could be on 2 or 3 as long as we keep the R before W ordering. V on 5 is fixed. That's our answer. Of course, it's the must. And then E, Y on 7. Y could be anywhere 6 to 8, so that's gone. So, of course, if your diagram told you only one other variable besides T was specified to a particular slot, you could have just looked for that variable mentioned as we see V and move on. I just wanted to be complete and show you all the choices. Next, number 5, if Q's on 5, so I'll lay that out here. If Q's on 5, we've got to have RWV and Z coming before it, since those guys have to come before Q. So we're going to have, of course, a V before Q, then we're going to have T and R as well, and then we're also going to have Z. This is forcing W to come later than Q, and then we're also going to have S and Y after it as well. So S, Y, and W interchangeable on 6 to 8, R, T, V coming, and Z coming before it somewhere. So it could be true except, find the 4 that could be true, eliminate them, and whatever remains will be your answer. So could we have Z on 1? Yeah, totally possible. Z could be anywhere from 1 to 4, so that's gone. Could we have T on 2? Yeah, if Z was between T and Q, that would work, so B's gone. V on 3, yeah, if Z was on 4, that would work, so C's gone. But W on 4, no, because W is forced later after Q. W's got to be 6 to 8 in order for Q to be on 5, so D's impossible and is our answer. I'll look at E though. Y on 6, yes, Y could be anywhere 6 to 8, so that's gone, leaving D if you didn't get it before. Next, number 6, if R was on 2, that is automatically forcing Z to be on 1, because that's the only way R could ever be on 2. Then we've got basically everyone else going as they typically do, T before V, and then S, Y, Q coming after the V, and then we're basically going to have W floating anywhere after R. So W could be anywhere from 3 through 8 as far as we know right now. And they ask us what must be true. A lot of ambiguity coming after R, but Z on 1 is our concrete must. So therefore, of course, if Z's on 1, it must be before everybody. So Z's on 1, E's our answer number 6. The other choices all either could be before or after, or specifically after, actually have to be after, making them impossible. Finally, number 7, if V is before Z. So we're basically taking the Z over here and putting it between V and Q more specifically. So I'm going to lay that out below just so you can see exactly what it looks like. We've got V before Z before Q. Of course, V is also before both S and Y. And then we have T coming before V, R coming even before that, and then W coming sometime after R. So relatively open-ended here. A lot of ambiguity. I'll run through the choices regarding what could be true. Could R be second? No, in this case, R has to be first because Z is coming much later. Could T be fourth? No, because Z has to come after it. Now the only things that could ever come before T would be R and W, making it T third at the latest, so that's gone. Could Q be fourth? No, Q is fifth at the earliest because we got to have R, T, V, and Z coming earlier than it. Could V be fifth? No, the earliest V could ever be is V could only be fourth here, because we have RWT before it, or if W is after it, V would even be third. So that's impossible, leaving E by elimination, Z on 6. And as we see here, we could have R, T, V, W, S as 5 things and coming before Z, then having Z on 6, Y and Q coming after it, just as an example. So that works, making E our answer to number 7.